Hello and welcome to TechScript. Today we are going to talk about TCP/IP model and OSI model. So the very first question is, why do we have to learn these models? What is their importance? So these models are primarily conceptual models and they standardize the communication functions of basic networks, right? So as students, it is very important for everyone to understand how the network communication happens over these models. But the next question is, why do we have two models? Why not one model? Right? So we've got two models over here, OSI as well as TCP/IP. So let's look why do we have two models and how they look like. So these are the models as you can see on the screen. On the left hand side is the OSI model and on the right hand side is the TCP/IP model. So if you go back in the history, uh, OSI model is far more scalable. It helps you understand the network communication in a better way as compared to TCP/IP model. However, as we know today, TCP/IP is really the model that we use. Now you can see these models are segregated into different layers, right? On the left hand side, we have OSI model, which is divided into 7 layers. And on the right hand side, we have a TCP IP model, which is divided into 4 layers. Why there's a difference of layers between these two models? Right? So you often must have come across network engineers talking in language in sentences and phrases like, this seems to be a layer 3 issue. This seems to be a layer 5 issue. This is literally the language of network engineers. So what they actually mean is that they are exactly talking about the issue or the problem that has arisen in the network belongs to which layer. Is it an application based problem? So you will often say, network engineers saying, yes, this is a layer 7 issue. Is it a problem with network? And you will often hear them saying, it seems this is a layer 3 issue, right? So this is how you will see that network engineers talk when it comes to OSI model or the TCP/IP model. But as I was talking about history, both of these models have been very popular. But if you know modern history of internet, we do have some sort of wars going on in terms of standard. For example, browser wars, which initially started between Netscape's Netscaler browser, and Microsoft's Internet Explorer, and ultimately Microsoft won, and the competition had to lose. Similarly, in between OSI model and TCP/IP model, there was a battle which was ultimately won by TCP/IP model. But it is very important to understand how network communication work with the help of these models. So I'll start with OSI model. Let me grab my eraser and I will just remove some text over here. All right. So let's start with the first layer. You can see TCP IP model's first layer, or the layer that starts from the top, is application. And over here, OSI has three different layers: application layer, presentation layer, and session layer. So let's talk about the OSI model first. And what does these layers do? So all of our applications which are network aware, right, quote unquote network aware, all the applications which are network aware belong to this layer, application layer. For example, Internet Explorer, for example, Google Chrome. The applications that can initiate communication or that can receive communication are network aware application, and they all belong to application layer. Now mind you, there are a few applications like Solitaire, right, that's available on Windows. You can play Solitaire. It's not a network aware application. It's made for you. It cannot initiate any sort of connections. It cannot receive any sort of communication. It's just made for the user, right? So only the network aware applications are available on application layer. So next layer is presentation layer. So what does presentation layer do? Presentation layer makes sure that the applications understand each other. So I'll take an example. Um, let's say there is you go to a bank and you want to withdraw some amount of money. So you will have a cashier sitting in front of a computer, and that computer will ultimately connect it to a server. Let's call it a database server, which holds all of your account information. So this cashier, you come over here, you ask this cashier, hello, I would like to withdraw, say, 2000 rupees. Fine. The cashier over here will take the request. The cashier will go ahead and enter your account number over here. The request will go to the database server, and database server will reply back with the amount and the information that it holds for your account. Now, these for obviously the cashier over here is using some sort of application on his or her screen or computer in order to communicate with the database. Now that application is actually a layer 7 application because it can initiate and receive communication. Now in order for this applications data to be understood by the database, they need to speak in the same language. I mean, for example, if I speak Spanish and the opposite person speaks only Hindi, obviously we can't understand. We need to find a common language to understand each other. Here's where the formats like HTML, JPEG, they come into the picture, right? So these should feel somewhat familiar if you are familiar with computers, because these are very common formats, and a server will probably understand and will understand these formats, and the application running on this computer, on the cashier's computer, will also probably understand it, right? I'm not talking about the protocols, I'm just talking about the standards, right? So presentation layer just makes sure that applications are able to understand each other. Now the next layer is session. Now the session layer's job is to make sure, yeah, before we move on to the session layer, presentation layer presents the data in a way that the applications are able to understand. It also has another job to do, and that job is to do encryption, right? It can do generic encryption, right? And yeah, I know, you might have questions like what kind of encryption. It's a generic encryption which is open source. Keys are available onto the public internet, but it's about, can you really break the encryption, right? So let's do a bit of recap. All the network aware applications reside on application layer. Then the presentation layer. The job of presentation layer is to make sure that the applications understand each other. And secondly, it also does some sort of encryption. Now the next is session layer. So what does session layer do? So session layer helps in making sure that there is a it manages the session with the server on the other side. Now I would suppose at the point that you woke up to the cashier, and you ask him to withdraw some money. It already his or her computer will already have a session going, and what I mean by that is it's got some communication started, right? And so the session layer will make sure that there is a valid exchange of communication happening over session. And so all these three things, the three layers that we are talking about, the application which knows to communicate across the network, the formatting of the data in a way that can be understood by both the sides, and the start and stop and the maintenance of the session, all happens at these three layers, right? Everything happens over here, right? And OSI divides the application layer into three layers: application layer itself, the presentation layer, and the session layer. However, TCP IP model combines all these three layers into one layer, which makes sense because ultimately it's the application that is doing all of these things, and we are not even talking about the network part over here, right? So I hope you understood what is OSI model, what's the application layer. Now we will talk about the next layers. Okay, so the next up is transport layer, and it is one of those few layers which is common between the OSI model and the TCP IP model. You can clearly see over here. So network layer, I think the choice of the pen color is not that great over here. Let me choose a different color pen. Um, Right. So as I was saying, uh, it is one of the few layers which are kind of same. Sorry, I selected the network layer earlier, but really the layer I'm talking about is the transport layer, which is same or similar across both the models. Now, you must have come across where a network engineers say, "Oh, this is a transport layer problem." So now what happens? Well, at the transport layer, the operating system makes a choice, and now that choice is actually dictated by the application layer itself. What do I mean by that? So I've got the same example where I have a cashier on his or her machine, and then I have a database server which hosts the information about all the accounts, right? Now, so as I was saying, at transport layer, um, operating system makes a choice, but that choice is actually dictated by the application. The people who actually made that application, they actually make sure that what choice the application will make, and the operating system, whether it is Windows, Mac, Linux, it will abide by the choice dictated by the application itself. So what are those choices? So we all know that you must have heard about TCP IP is a suite of protocols, right? It's a suite of protocols. It includes TCP, UDP, ICMP, all sorts of other transport layer protocols, voice protocol, VoIP protocols, right? It's a suite of protocols. Now, out of these protocols, a choice will be made, right? But primarily, the choice is made between two types of protocols. And those two types of protocols are TCP and UDP. Now, UDP stands for User Datagram Protocol, and it has got two really primary characteristics. The first one is it is unreliable, really unreliable, and the second is that it is fast, extremely fast. Now, now imagine where will we use UDP? It is used when we have real-time applications. Example, live TV streaming. We all know that there are live TV shows that are streamed all over the internet. That's something not new, but we really need a fast communication to happen over here, and that is why the UDP comes into the picture. I'll give you another example which will help you to have a clear understanding of UDP. Now, let's say there are two people who are talking to each other over a phone call, right? And let's assume that every word that they speak is a packet. Now, I've got four packets which are being sent by this person over to this person. Now, he says, "I am here," right? So let's ignore the third packet. So these are the third packets, three packets. I am here, right? So let's say the very first packet is dropped, right? It get drops or it's lost while making a communication, and you over here only hear the last two words, "am here," right? So however, you will kind of figure it out. The other person is trying to say, "I am here" or "am here," right? So there's no need to send this packet again, There's no need for this device that you are using, that this device will go back and ask the other person's device to send this packet again, right? So so that's how the UDP works. I mean, we need UDP to make sure that there's a fast connectivity for applications like streaming or video conferencing or voice conferencing. Now the next up is TCP. Now TCP is actually the major protocol that is used. I think 99.9999% of applications use TCP as a primary mode of communication, or the protocol that they use. Now it is reliable protocol. What does it mean by reliable? When I say reliable, if during a communication a packet is dropped, the receiver will ask the receiver will ask the sender to send that packet again. That makes it more reliable, right? It acknowledges all the packets that a receiver will make sure, the device over here will make sure that it acknowledges all the packets that it has received from the sender, right? So as I said, two choices are made, either TCP or UDP. The choice is dictated by the application to the operating system, right? Now, for example, web browsers, uh, Google Chrome is um, a TCP layer application. It's a layer 7 application, and it will always use TCP whenever you type in a website. Okay, now we will talk about the second choice. The first choice is that made over here is which protocol to use, whether TCP or UDP. Now, the second choice, let me clear few of the scribbles over here, and then we will talk about the second choice. Right. The second choice that is made over here is of port numbers. What are port numbers? Now, this database server will not only be running one application, it might be a mail server as well, right? It will also be it could be a web server as well, right? It could be a NTP or a FTP server as well, right? It could run multiple. This machine could run multiple servers on it. So how to differentiate these applications? The differentiation is done with the help of port numbers. And how? All these applications, mail, web, FTP, will have a port number. Now in TCP world, we have 65,553 application, three port numbers. I'm not sure about the exact number this, but the number is around about 65,000. It's a little over 65,000. So we have got these numbers of port numbers, and all these services that are running on this database, or this server, sorry, will have a port number attached to it. For example, in general, the websites or the web servers will accept connections on port number 443 and port 80, right? HTTPS and HTTP, right? Mail will have their own port number. FTP generally accepts connection on 2021. So when this cashier sitting over here will initiate a connection to this server, say asking withdraw 2000, right? So that will become a packet. Just for an example, I mean, that's not how really packet is, but I'm trying to make you understand. So next to this packet, it will put a destination port number, say 5000. Maybe this is a port number on which the application, the banking application running over here, listens, right? So when this packet reaches over here, this server will open up the packet and it will look at the destination port number. Destination port number is what? 5000. Okay, this means it is for the application for the bank. If it was 80, right, then it's not for the application running the bank infrastructure. it is maybe for the web services, right? So this is how it differentiates the applications. The port numbers are used to differentiate applications, and it is vice versa true as well, right? Mind you, the port numbers are not just only for the server, they are also helpful to keep the differentiation on the client side as well. Now we all do multitasking. We have Spotify or iTunes running to listen music. We have browser with multiple tabs, right? So every connection initiated by a client, the operating system will also insert something called source port. Let's say in this example the source port is 200, right? And this cashier has two requests going on at the same time. One is making sure that it is withdrawing the money from someone's account, and the other application is making sure that the some money is being added to some other customer's account. So it will initiate two connections with different source ports to make sure when there's a reply back from the server, it is to the correct connection, or to the connect tab of the browser or the application that the cashier has, right? So I think that's it. This is what actually happens at the application layer. Sorry, at the transport layer. It is the choices between the protocols, usually TCP or the UDP, and the second choice is what source and destination port numbers are to be used. Now we will go ahead and talk about the next layer. So coming on to the next layer, we will be talking about the network layer. And here is the layer, or here is the difference in the naming convention in both the models. OSI model likes to call it network layer, and the TCP/IP model likes to call it internet layer. Why? I mean, the answer could be straightforward, wherein TCP/IP model is looking at the larger picture. They are already calling it an internet, and whereas OSI model's naming convention is more generic, they're calling it network layer, right? So this is the layer. The important part is this is the layer where we as network engineers have some sort of control, or we can say complete control, right? But how? Let's have a look. So in our example, there is already a cashier that is trying to make an entry registered over here for a withdrawal of 2000 rupees, right? Which means the cashier's computer has to talk with this database server. Now, uh, how do we as humans talk, right? How do we know we have to talk to someone, right? We call someone and then we make sure that we relay our communication, or we relay our message, right? Similarly, these devices also have to talk to each other, and they can't until unless they have a name. And that is where the network layer comes into the picture. At network layer, what we do is we give some sort of logical addressing, right? Which we actually call IP addressing. So IP addressing, just a generic, talking in simple layman terms, is it's a name that we assign to devices. Now let's say I assign an IP address over here as 10.10.10.20, and this server, or the database server that we have in our example, has an IP address of say 192.168.1.1, right? Sorry, I need to put the last two octets under the first two octets, but you understand the point here. I have two devices. They have their own name, which means they have their own IP addresses, right? And they want to talk to each other. So besides the port numbers and the choice of protocol, if you remember, that we make in the transport layer, right? In network layer, we also add another header, right? So we have a data which says that 2000 is to be withdrawn, and this entry has to be registered on this server. right? In addition to that, we will have a header with source port and destination port. We'll also have a header that states this is a TCP connection. We also will have now a source IP and a destination IP. Source IP will be 10.10.10.10.20 and destination IP will be 192.168.1.1. Essentially telling this client that where to go and essentially telling this server from where the connection is being sent, right? So it's all about logical naming of our devices so that they can call out each other and they can talk to each other. So that is it. This is what happens at network layer. And as I said, the choice lies over here. I, as network engineer, decide what IP address I have to assign to these devices. So now we will move on to the next part. Okay, so the next up is the data link layer and the physical layer if we talk with respect to the OSI model, and but TCP IP model again combines these two layers and call it a link layer, right? So let's understand what is physical layer and what is data link layer, right? And then we will try to make sense that why TCP IP model combines these two layers into one layer. Now physical layer is essentially how we send traffic across different devices. We could send traffic between these two devices, as you can see, with the help of wires, right? Now, uh, this is over here is a local network, and this is over here is a local network. As we know that these are routers and these are switches. Every interface of a router is actually a network, right? I'll not say again, but I'll repeat again. Every interface of a network, of a router, is a network, right? So so we can communicate, or we can make sure that the communication happens. We can plug in a fiber cable, so the communication will happen with the help of light signals. We can also connect copper cables, then the communication will happen over electrical signals, right? Or we cannot connect anything, and the connection or the communication can happen with the help of Wi-Fi, which means radio waves, right? So physical layer actually talks about these connections, or the mode of communication. It talks about the mode of communication. So it's very simple and straightforward. What we have to understand here is in more detail is data link layer. Now going back to my example, let me grab an eraser and remove some scribbles over here so that I have more space, or some space to write. Just bear with me, right? So let me grab a pen again. Now, as I mentioned earlier, this is a local network, and the layer 2, we call this layer 1, layer 2, 3, 4, 5, 6, 7. So this is layer 2. At layer 2 helps the devices to communicate within the local network, within a given network, where to go, right? So in our example, we have this data of 2000 rupees. The information is to be registered on this server, that the withdrawal has happened. Then we have the port, source port and the destination port. Then we have the source IP and the destination IP. We also choose our protocol as TCP. Now we will choose MAC addresses. Now, MAC addresses are physical addresses. They are not logical, unlike IP addresses. So in our last example, we said that we will name the devices, and we'll give them names in terms of IP addressing, right? So, but IP addressing is logical. MAC addresses are physical, and every network device has a MAC address. It's a physical address which you cannot change. Now, within the local network, a source MAC and the destination MAC will be applied or will be attached to the packet or inside the header itself. So over here, the source MAC will be of this computer, and the destination will be of this. As I said, the MAC addresses helps you to communicate within the network, not outside the given network. So over here we have got three networks, one, two, and three. We have got three different networks. So MAC address will help this computer to reach the router from where it knows the path to the destination. We might have another router over here, but this router might not have a path to reach over to this database, right? So MAC address will help us to find out the network device within the local network that can help us to reach to the end server, right? So this is how the entire communication happens with the help of TCP IP model or the OSI model. In our next video, we will talk about the communication. We will describe the network communication using the OSI and the TCP IP models. I hope the video is informative to you, and I would like that you support us. If you like my videos, please like them. Please subscribe to this channel. I would like to thank you for viewing.